Give me an overview of your research, what you and your colleagues were looking to examine.
My colleagues and I at Georgetown University, Rachel Barr is this colleague that I collaborate with. We both are very much interested in social learning and the development of social learning in children. And social learning is one of these skills that appears early in development, but it has a long developmental trajectory. In effect, we become better at learning from others. The amount of information that we learn, the accuracy by which we're able to replicate what we learn increases with age. And one of the things that I learned in my own projects is that, to our surprise, there is this lag in the development of a particular abstract form of imitation. It's a sequence or a pattern type of learning where you have to sequence spatial, where you have to copy is a spatial pattern. So imagine that the pattern is something like top of the screen, bottom of the screen, left of the screen. Another way of thinking about this is imagine like the numbers on a keypad for an ATM, but now imagine that like there are no numbers on the keypad. It's just you just have to remember the spatial pattern, right? So and we all could do this. We could go to we could stand in front of the ATM, close our eyes, and imagine the pattern that is our PIN. So that's the kind of abstract spatial patterning we were asking kids to in effect copy, right? And what we found was that 3-year-olds were surprisingly bad at doing that. Even though they were good at copying other types of sequences, they were really bad at copying those types of spatial sequences. So this has other links to many other things. So kids have different, again, strengths and weaknesses, like I was saying, in their imitation skills, and it improves over time. And this particular peculiarity in their spatial imitation abilities suggested that perhaps it's something that is malleable or can be shaped by experience. And so this project kind of was inspired by that. And so we had about a little bit over 100 kids, and we had 4 different groups of kids that went to 3 different types of training. And so at the very beginning of all groups were first tested in this spatial imitation task that we know that they're bad at. So we only included the kids that initially failed. So we did like a pre-test, right? So we had them imitate a pattern, and the ones that failed went on now to the training phase. Like in effect, can we make them good spatial imitators, right? So we're going from, can we go from bad to good? And so all of the kids in all of the groups initially failed that test, so they couldn't imitate the spatial pattern. And then they went to 4 different types of training. So one training was, we're just going to play back and forth spatial imitation pattern. So the same game. So I do the spatial pattern, now you do the spatial pattern. You try, you fail, let me try again. Let me show you the spatial pattern, now you try. And we did that for about 10 minutes. And we scaled it in difficulty. So as they got better, the sequences got long, the spatial patterns got longer and more complex. Right? And then at the end of those 10-minute intervention, we gave them the same spatial imitation test we had given them at the beginning, but with a new spatial pattern. So now as they could imitate, and then we compared their pre and their post test, and we saw the difference.
And what did you find?
And what we basically found is that they improved, and they improved significantly, very, very robustly. Just like a 10-minute, very brief intervention significantly improved their spatial imitation performance. The other type, that particular group was, right, they got the exact same training for the exact same task. But we had other groups, like I said, like other control groups. The other control group is they did a different imitation task. And that imitation task involved them not copying sequences of spatial patterns, but sequences of individual items. So now imagine that instead of being 3 identical pictures on the screen that you have to remember where they are in space, you have to remember 3 distinct objects. So imagine a picture of an apple, a boy, and a cat. And you have to touch apple, boy, cat. And then the next time the pictures disappear, and when they reappear on the screen, they appear in a different configuration. So now space, you have to ignore where they are in space and remember apple, boy, cat. But this task is actually one that young kids are actually good at. So they're good. The same 3-year-olds that fails the spatial pattern will imitate this one, which is surprising because it seems harder. but it's actually easier for 3-year-olds to imitate this particular task. But now notice that there are two different types of things that you're imitating, right? One, you're imitating a sequence of distinct things. The other, where you're imitating some abstract spatial pattern. So very, very different things that you're imitating. So anyway, so this group got the same type of training. So we went back and forth imitating Apple Boy Cat or, you know, three other pictures. And then we gave them the spatial task, the spatial imitation task, to see if there was a transfer from one imitation training to another. And there was, but not as good as with the spatial one. So perhaps not surprisingly, but there was an evidence that the practicing imitation back and forth, even if it was an unrelated task, improved imitation performance on a different task, which is also kind of interesting.
Why are these skills important, and why are they important starting at this age range?
Virtually every single thing that we do from the moment we wake up to the moment we go to bed involves sequences. Involves stringing things together, and not just stringing things together in any order, but stringing things together in a specific order. Take, for instance, these sentences that are coming out of my mouth. They are discrete words that have to occur in a particular order. Even the sequence of this interview. You ask me a question. I wait, I listen, I think, and I give a response. But there's a sequence and an order to how we do every single thing. And those sequences are different, right? So there are linguistic sequences that involve distinct things, but there are also spatial sequences. I mean, think of brushing your teeth, right? And the discrete sequences involved with grabbing your toothbrush, putting toothpaste on your toothbrush, moving that toothbrush in discrete positions in space in your mouth, right? So that's a kind of spatial sequence that we're doing that we, again, don't think of a spatial sequence, but that's what it is, right? So just take any behavior and you'll notice immediately that there are steps and there are sequences and the order matters. And of course, kids aren't born knowing this. They have to learn this. And that learning is, some of it is easier and some of it is harder. And so these tasks that we've developed, in effect, tap at this fundamental aspect of sequencing that generalizes to all sorts of other sequences in our everyday lives.
What did you find? What were the basic findings of what?
We had these different groups of kids that received these different types of interventions to see if, in effect, we could improve their spatial imitation performance. And it's specifically 3-year-olds that we were doing, because the 3-year-olds, by the time they're like 4.5, they're doing really good in both of these tasks, in both the tasks that involve sequencing spatial patterns and tasks that involve sequencing discrete items like apple, boy, cat, right? They become really good. But 3-year-olds show this difference where they're really good in the sequencing items versus sequencing spatial patterns, where they're bad at sequencing the spatial patterns. And what we found basically with these interventions is that 2 of the 3 experimental interventions were good. They improved spatial imitation performance. One of them very, very robustly. That's the one that's not surprisingly, because in effect, the training was exactly like the test. It was basically like training for the test. So of course you did better. The one that was a little bit more surprising was the one where we trained them on a different task. It was also a sequencing task, but it involved, right, sequencing discrete items that was completely independent of space, because remember the items appear in a unique spatial position. So if you focus on space, you would make an error because a different item would appear in different positions in space from trial to trial. And that one too seemed to improve imitation performance on the spatial task. So that suggests too that there are both specific aspects of intelligence that are associated with imitation and more general aspects of intelligence that are associated with imitation, and that different types of interventions need to target these things, right? So you could target the ones that are task specific, and you could target the ones that are task general. And the task general ones are better in the sense that they generalize to more types of problems and more types of skills.
Why is it important to know?
Well, it's important for teachers in terms of like when you present information to kids, at what age you present information to kids, the type of information that is most optimal for kids to learn at a particular phase in development, the types of transfer tasks or the other types of tasks that you want kids to learn. Like how do you make a link from teaching one skill to now you want kids, right, to take what they learned here and apply it to a problem here, right? So you knowing what information is transferable from one task to another, what kids can and cannot transfer, that's what these tests tell us, right? Because it's not like kids are not universally, they don't universally come with all this knowledge, and these tests suggest that some things are more intuitive for kids to learn and to then transfer to other problems and other types of skills and other types of tasks.
What's important for parents to know about this research?
Having this knowledge could give parents knowledge as to, like, for example, what toys to get kids and what types of activities to encourage kids. There's a lot of controversy as to how much tablet time kids should be allowed to use. So this is a concern. Like I said, like we would never just give a book to a kid and tell them, go have fun with a book. Right? We know that kids really, really benefit from a parent being there reading with them. The same thing applies with these tablet tasks. So tablets could be an amazing tool, just like books and other types of media could be amazing tools, but they really do need a parent to be involved. They need a parent to be there, to interact with them. And this particular study suggests that this back and forth reciprocal imitation and turn taking has potentially generalizable effects, right, and transferable effects, meaning that what is learned in that interaction between the parent and the child, or a teacher and the child, can be transferred to other problems, to new problems that the child doesn't already know.
In terms of parent behaviors or parent takeaways, are there specific things that parents can change or can think of or do differently, or even introduce as a result of your research?
Potential simple thing that parents could do is, again, also depending on the age of the child. So these are presumably preschool age kids. So ask your kids questions. Have them show you things, right? So, you know, parents are busy, and particularly, you know, single parents. Like my mom, I grew up in a single parent home, and so I understand very well like how challenging this is, and one of my best friends is a single parent. And, you know, parents could still be engaged, you know, if they can't be sitting with a child with a tablet or with a particular learning tool, parents could still be engaged in the sense that they could be asking questions their kids periodically, like every minute or so. It's like, you know, what are you doing? Tell me what you've learned. What is that? Have them show you things, right? So in this way, right, like kids are not only paying attention, but it also forces kids to reflect and translate information that they're learning, and it gives you an opportunity, you as the parent, gives you an opportunity to then, if you feel that something is going on that you are not sure about, it gives you an opportunity to then come in and get involved and learn more about what your child is doing, and then adjust your behavior accordingly.
Do you have any suggestions for activities or ways that parents can still present this information and still help their children with the patterning and the spatial skills, even beyond the tablet?
The cheapest thing is Legos. It's a simple, it's a simple, amazing toy that's out there, product that's out there that is good. It's associated with the development of geometry skills and spatial skills in children. It also involves sequencing, right? Because you have to stack things in a particular way and arrange the Legos in a particular way so that they support each other and that you could build structures that are standing. It engages a kid's imagination, and it's a cheap, low-cost toy that kids like. Everyone likes to play. Kids and adults like to play, right? Play varies, of course, between ages, but play is an inherently fun thing, and the most rewarding play is the play where you learn things that involve challenges. We like challenges. We seek challenges. Games that become predictable that we're super good at, we get bored of really, really quickly, right? So that's another important thing for parents to know, right? That like kids are curious. Kids want to be challenged. Kids want to learn. And learning, if it's done right, is a lot of fun. And parents could get in the mix too, because right in the course of them learning, they themselves could be learning about how their kids learn, which is a very practical thing to know and to have, very practical knowledge to have. So play is rewarding because learning is rewarding. But another thing that we know is super rewarding is imitation. We love imitation. It's an intuitive way of learning. Imitation games are also inherently rewarding, particularly for little children. So children find adult models very rich models, very interesting models. They focus a lot of attention on what adults are doing. So imitation is also one of these very powerful and a natural way by which children learn. So this is, I think, another thing that we tapped into our study, that this reciprocal imitation, that I go and you go, not only has a communicative quality, right? It's like conversation, but it also taps into this desire of sort of an adult, in effect, imitating the child and then allowing the child to imitate the adult. And it's a very rewarding and powerful way of learning for children.
Can you give me some examples of areas where kids are playing, where parents may be interacting too, and they're learning these kind of patternings or patterning or spatial skills?
When you walk into the building zone, which is the room for the preschoolers, there is a wall, and the wall has these like various chutes that can be modified in all sorts of ways, and kids, right, could put marbles and run these chutes down. So that's another example of a patterning task, right, and a spatial task, because you have to know the connection, physical connection, and spatial relationships, and how those spatial relationships are important to have this marble basically travel down the chute in many different ways and in many different directions. And kids love that task. So that's another one I think that you guys could focus on to sort of get at the same idea of like how their patterns and spatial sequences everything and so many things that we do. And they're also huge size, they're not Legos, but they're kind of like building blocks, but huge ones. They're outside in the main hall and they're inside the building zone as well. So you could also record kids doing that, and it's the same kind of idea. So you could use the Lego example of kids using spatial knowledge and spatial relationships and spatial patterns to build structures.
Is there anything that I didn't ask you about this research or about what you would like parents to know?
I think my general advice to parents is, as I was saying earlier, is that I know parents are busy, and but there's a lot that parents could do. So while, so I'm just thinking of my mom and my own family, right, and how it was, so I would be entertaining myself either drawing or playing with Legos or playing with one of my toys. And my mom will be cooking or cleaning, but just periodically she would step in and ask me questions. What are you doing? What's that? I mean, just that simple checking in, right, and engaging your child while you're doing events, I think is something that's both rewarding for parents and for kids. So I would just try to encourage parents to try to do that, try to remain involved as much as they can. I know it's a challenge. I'm speaking from personal experience, but we know it's very, very, very rewarding for children and very, very beneficial.